Hey guys, Brian Schultz here with the Actually Tiny House Project, where we are exploring smart, simple, sustainable tiny house design and giving you some building tips along the way. Now, the topic of today's video is insulation. We're almost done insulating the tiny house here, so I felt like it would be a good time to just take a moment, talk about the overall thermal performance strategy for this building, the types of insulation we used, why we used those types of insulation, and also how we mixed and matched different types of insulation for different performance characteristics. Now, once I'm done with all that, I'm going to have Liz come on, and she's going to give you a whole bunch of practical tips for installing your insulation to make it fast and easy. All right, so before we can start talking about specific insulation materials, I want to rewind all the way back to the planning stages of this building, where we were first deciding how to frame our walls, where to put our windows, and how big to make those windows, because those two factors are going to have a bigger impact on the overall performance of your building than what type of specific insulation you're using. Now, this isn't rocket science. Basically, less wood in your walls and smaller window areas equals more room for insulation, which means that you're going to have a more thermally efficient house. And this is especially important in tiny houses because typically we have thinner walls and thinner roofs than a conventional house, both because we're trying to maximize our interior space and also because we're trying to minimize the weight of the trailer, which puts us at an automatic thermal disadvantage, which is why it's so important to be careful with your framing and careful with your window planning. So I made a separate video that just covers framing and window placement. I'll make sure I put a link to that, and you'll have to check that out for more in-detailed information. Right now, I'm just going to talk about the overall insulation envelope from the bottom of the building all the way to the top. So just a quick aside here on tiny house thermal performance. You could make an argument that this really doesn't matter because tiny houses are so small that they don't use very much heating energy in the first place. And that argument is true. However, if you're designing houses that you want to be as close to possible as net zero energy consumption, or you're designing them to be used off the grid like mine is, where you're not going to be having a continuous overnight heating source, having a leaky house or a house that is poorly insulated is going to result in a pretty dramatic daytime-nighttime temperature flux. And speaking from personal experience here, that's going to mess with your sleep, it's going to create problems with condensation, and it's going to make it really hard to get out of bed in the morning. So really paying attention to your framing, your windows, and your insulation details is going to do a huge amount to really increase the overall livability of the space. So before we talk about insulation, let's start out here by talking about air sealing, because this is another one of those things that's going to make a huge difference in the performance of your building, although not necessarily for the reasons that you think. Basically, air sealing is using a little bit of foam to seal up any cracks, to seal up around your electrical boxes, and also managing your house wrap details so you don't have excess air infiltration or exfiltration from the building. And the reason that you want this isn't necessarily because you don't want air coming into your building for thermal reasons, because you need air coming into your building so you'll have enough air to breathe and also so you can manage your moisture content. The reason that you want to block air from coming in through your walls is because you don't want to be pulling your air through all of the toxic construction materials that you use to build your house. So formaldehyde from the plywood, particulates from your insulation, any chemicals that might be coming off the various sealants that you used, that's all stuff that you don't want in your living space. So sealing up your house really well and then managing your ventilation with either passive air vents or active blowers is going to be a much better strategy for bringing air through your house. All right, so our first layer of protection is on the bottom of the trailer here. We've got a 1-inch layer of XPS foam that's sitting in the bottom of the trailer pan. It wraps up the sides of the trailer pan and then out to the flange of the trailer pan, butting right up against the sill plate. And the reason we used XPS foam in this application was to create a continuous thermal break across the bottom of the floor, but also to create a moisture resistant layer, because anytime you've got metal, you're going to have condensation. And if you put fluffy insulation right on top of that, you have a potential recipe for water to wick into there and create a habitat for mold. And some insulations are better and worse for that, but it's better if it doesn't happen in the first place. Now, XPS is going to be your least environmentally friendly choice. It has a really high carbon footprint and it's really toxic. But the reason that we decided to use it is because it's very inert and it's also a very compressible foam, which means that you can frame right on top of it within certain limits and have it serve a little bit of a structural purpose as well. Now, sitting on top of the XPS, we have a 2x6 frame that supports the floor that's filled with the R23 6-inch rock wool. Now, rock wool is our primary insulation choice for this building. The reason that we chose it is because it's relatively inexpensive. It's about 15% warmer than fiberglass. It's relatively non-toxic. It's moisture and mold resistant, it's fairly easy to work with, and it has a low carbon footprint. So we put rock wool under the floor, we put rock wool in the walls, and we used rock wool in the ceiling, but we did that combined with some foam, which is what I'm going to talk about next. All right, so before I talk about our kind of unique insulation buildup in our roof here, I want to talk about the problems that tiny house builders face with roof insulation in general, namely that we don't have enough space for insulation because we're trying to keep the heights of the tiny house as low as possible and the interiors as high as possible, and also not trying to overload the top of the house with some really heavy framing. So in standard residential construction, we use 2x10s or 2x12s, and then there's fluffy insulation that can fit in there that gives you an R30 or an R40 or even an R50 roof, which is really what you want inside of a house, because your roof is going to lose heat much faster than any other part of your structure. It's also going to have a lot more vapor pressure, which really matters if you're going to be using paneling, because if you're using paneling, no matter how good of a vapor barrier you put behind it, you're going to have air leakage from those pinholes up into your roof cavity, which means that you're going to have ventilation. Now, even if you don't have air infiltration from below, ventilation is still important up above, because the underside of your plywood, if it's really cold outside, is going to condense water, and that water is going to build up in the roof cavity if there isn't an airspace to let it flow out. So as a tiny house builder with 2x6 rafters, you have a pretty difficult problem of having, one, enough space for enough insulation so your house is warm, and also maintaining a ventilation space so the roof cavity can vent. And there's really only a couple insulation strategies that I've seen that fulfill all the requirements of what a roof needs to be, which is something that's not going to build up vapor and also something that's going to be warm enough. Now, the first thing you could do is you could just fill the entire roof cavity with spray foam, which is going to give you a really high R value, and it's also going to give you a totally vapor exclusive environment so no water can build up. Now, the downside of spray foam is that you almost have to get a professional to do it for you. It's really nasty stuff to work with, and if your building ever catches fire, it's going to be very exciting to watch the whole thing go up. Now, the other option is you could just get larger framing lumber and rip it down so you have a little bit of an airspace over your standard insulation size. But if you're doing that with 2x6 insulation, you're still only talking about an R21 or an R23 roof, which in my opinion is just not a warm enough roof. So the strategy that we decided to go with is kind of a hybrid between foam and rock wool. And this is something that we learned about from our friend Darren Williams from ShelterWise. We actually paid him to come over and do a consult with us. So Darren's system here starts with some 2-inch polyiso foam, and polyiso foam couldn't be more different than the XPS foam that we have in the bottom of the trailer. XPS foam is super nasty for the environment, whereas polyiso has a surprisingly low carbon footprint. It's a little bit less toxic. It has a higher R value, although it is a little bit more expensive. So the way that this gets installed is we put little plywood blocks right on top of it and glue them in place, and we cut sheets of this as wide as our insulation bays, but just a little bit narrower, and then we push it all the way up to the ceiling, and these little plywood blocks that get glued on top hold a little bit of a space for ventilation. And then that ventilation space is completed by putting core vent, which is the same vent that we use for our siding, right on top of our bird blocks. So the bird blocks at the end like this, the core vent, and then the sheeting comes down on top of it. So any moisture that builds up in the roof cavity is going to flow over the top of the foam, past the plywood blocks, and then out the core vent to make sure that the roof cavity stays dry. So just a couple quick tips here for working with the polyiso foam. First up, you want to cut this on a table saw. That is so much easier than any other way that you can cut this insulation. You just want to make sure that you're wearing a mask when you do it. Also, I would recommend cutting this 1/8 of an inch narrower than your actual joist bay, because if this is even slightly wider than the joist bay and you try to push it up into place, it's going to break on you and it's going to be a really frustrating mess. Now, once you've pushed this all the way up to the roof with the little plywood blocks on top to make sure you leave room for your ventilation, next, you can go around with push pins and you can support it every couple feet, and that'll hold it in place temporarily. And then what you can do is go around with some spray foam and spray foam the perimeter, which will both seal the air cavity and it'll also glue it up into place. Now, once I've got all of that done, next thing I come back with the rock wool from underneath and I press it up into there. Now, the rock wool, incidentally, isn't nearly as warm as the polyiso is, but it's a lot cheaper, It's a lot more fire resistant, and it's also less of a toxic product. And the overall buildup here between the R15 rock wool and the R13 polyiso ends up giving you about an R28 roof, which is still just a little bit below the minimum of what I like to see in a roof, but I feel like it's at least acceptable for a tiny house. All right, so that's our overall insulation strategy. Next, I'm going to hand you off to Liz for some tips on working with the rock wool and also working with the foam.
All right, so let's talk about air sealing. So before I put any insulation into the walls themselves, I'm going to walk around with a can of expanding foam, and I'm going to foam any gaps, cracks, the areas around my windows and doors, any penetrations where, say, wires pass through the exterior of the building, and as well as the holes in my electrical boxes where the wires actually pass into the boxes themselves. And I like to take this opportunity to also foam behind the electrical boxes, because usually there's a really small space there between the box and the plywood, and it's difficult to stuff fiberglass or rock wool back there. It's just not going to work. So let's talk about foam, because not all foams are created equal, and there's a couple different application methods. Now, most commonly you're going to see these single-use cans. They come with this nozzle that plugs into them. These are fine. Personally, I don't love them. The nozzle is kind of floppy, and it makes it harder to control the foam. They tend to be messier, and they are single-use, which means unless you're doing all of your foaming at once, you're going to end up wasting material and having to buy another can. What I prefer is actually a professional foam gun, and you don't need to make a huge investment on these. A $20 gun off the internet is going to be just fine for a tiny house. These accept a slightly different type of can. The cans, you can still get them at any regular hardware store, but they've got this screw top that fits in right here. And this just gives you more precision with a longer nozzle, and you've also got trigger, so you're able to better control the flow of the foam. And this is just really great, especially, you know, when you're reaching or trying to get the foam into an awkward space. It just makes a world of difference to have that additional control. Now, if you do get one of these, you can leave a can in it for up to 30 days, but you do want to make sure that you get a can of gun cleaner as well, so that you completely flush the thing out before you put it away and store it. Now, you do want to pay attention to which can you're picking up when you go to the store. Most commonly, you're going to see these orange cans, and this stuff is fine for gaps and cracks, but you absolutely do not want to use this around a window or a door. For windows and doors, you always want to make sure that you pick up the blue can. It's a different formula of foam that doesn't expand quite as much, so it doesn't distort the window or the door frame, potentially binding the door or window. So this is rock wool. It comes in these bales, and a lot like fiberglass, it comes in bats that are designed to fit between typical stud bays. But unlike fiberglass, rock wool is just a lot denser, it's a lot less compressible, it holds its shape better, and it's designed to friction fit within the studs. Now, like fiberglass, this is an itchy material to work with, but it is so much less itchy than fiberglass. But you still want to make sure you're wearing gloves, respiratory protection, and it's a good idea to have long sleeves and long pants on as you work. And if you're working overhead, make sure that you wear safety glasses so it doesn't get in your eyes. So unlike fiberglass, where you would cut it with just a regular craft knife, what you want to use for rock wool is actually a saw. Now, this is a Japanese saw. It could be any kind of saw. It could even be a bread knife, honestly. And it just saws just like you're cutting a piece of bread, nice and stable like that, keeps its shape, and there you go. Now, when it comes to insulating around the wires that are in your wall, what you can actually do is just cut this halfway through the thickness of the rock wool, and then you've got this gap, so you can fold the rock wool open, and as you're installing that in the wall, you just wrap that around the wire, and it completely encapsulates your wiring run and makes insulating around those wires really easy. Now, rock wool recommends that same folding technique for insulating around pipes, but personally what I like to do is plan my bats so that they end about 4 inches above my pipe, and then cut into the top of the bat so that I create like a pocket that I can slide up, and I can slide a piece behind the pipe and then fold this up, and so it covers the pipe and encapsulates it nicely. Now, for cutting around your electrical boxes, you can measure and cut for a box anywhere within the bat, but personally what I like to do is, again, plan the placement of my bats so that one edge of my bat is going to align with an edge of my box, so I only have to cut out a corner. So what I do is, first I'm going to measure for the placement of my box, and I like to just take my saw and just kind of score where I need to cut, and then I'm going to go ahead and cut out that corner piece. And I always cut that corner out, make the corner a little bit smaller than the box itself, again, so that you've got some space to sort of friction fit that in there and it's going to hold nicely in place. Now, speaking of friction fit, when you're cutting a bat down to fit into a narrower stud bay, you do always want to make sure to give yourself about ½ inch of overage on your width. And that's just to ensure that it does friction fit within the bay. And how this works in installing these bats is you just press one side up against the stud, and then you can just tuck the other side in, and it just holds itself nicely in place like that. And so that's the basics of rock wool. All in all, it's just a super easy material to work with. So that is our tiny house insulation video. Now, one last thing I want to mention before I go is definitely hang on to any scraps you have of that polyiso foam, because you can piece that together later and you can use it to insulate around your wheel wells. And speaking of wheel wells, we've got a completely separate video where we talk about how we boxed out our wheel wells, how we insulated them. It's a little different from what you see other folks doing, but it's a really clean, really low profile solution. So if you're interested in that, I'll put a link to that right here. If you want to follow more of what we do, you can find us online at actuallytiny.com, where we've got more videos like this one and a growing library of tiny house resources. You can also find us on Instagram at actuallytiny, where we post photos every day of what we're working on and time-lapse videos showing everything we do, including hanging this insulation. So that's all for now. Thanks for watching. Have fun building your tiny house.